Please like and subscribe. At exactly 8:30 in the morning on May 19th, 2025, the air inside a concealed coastal bunker vibrated with tension. An operator from the Security Service of Ukraine, known by the call sign Sokol, sat motionless in the dim light. His world had narrowed down to the digital feed projected inside his first-person view goggles. He waited, his breath steady, until the authorization finally crackled through his earpiece. Send it! Within seconds of that command, a Ukrainian-built quadcopter drone screamed to life on a hidden patch of coastline. Carrying 3 kilograms of high-grade plastic explosives, the machine began a 35-kilometer journey across the churning waters of the Black Sea. Its mission was to eliminate one of Russia's most critical surveillance assets, a magic eye that had been preventing Ukraine from reclaiming control of this strategic region. Sokol remained safely ensconced in his camouflage bunker, exactly 35 kilometers away from the target on Snake Island. His weapon was a standard 10-inch frame quadcopter, a device that looked deceivingly simple, assembled from electronic components of Chinese origin in a small Kiev workshop just days earlier. But this was no longer a toy. Zip-tied to its belly was a custom explosive device, specifically designed to destroy hardened radar systems and eliminate any personnel within a 5-meter radius. The target coordinates had been programmed into his ground control system hours prior. The Neva radar installation on Boyko Tower Alpha, one of the offshore gas platforms seized by Russia. The Neva system provided a detection coverage of 45 kilometers, a lethal radius that had hampered Ukrainian military operations for months. Taking it out would kick the door wide open for Ukrainian forces to move freely. The drone system Sokol was operating represented the democratization of precision warfare. A $500 racing drone transformed into a guided missile through Ukrainian ingenuity. The quadcopter's 4 brushless motors spun up to 20,000 revolutions per minute as the pilot initiated takeoff from an improvised launch platform hidden among the coastal reeds. Unlike traditional military drones that fly autonomously, first-person view systems provide real-time video feeds through an analog transmission, an older technology that is surprisingly resistant to modern electronic jamming. Sokol could see exactly what his drone saw through the goggles strapped to his head, creating an intimate connection between pilot and weapon. This link made these drones devastatingly accurate against point targets. The flight profile was planned to avoid Russian detection. Rather than flying in a straight line toward the target, the drone followed a complex zigzag pattern, staying below 50 meters in altitude to remain under the enemy radar horizon. At 65 kilometers per hour, this 35-kilometer journey would take just over 45 minutes due to the evasive maneuvers the drone was forced to execute. As the drone lifted off and began its approach toward the Boyko Towers, Sokol could see the vast expanse of the Black Sea spreading out below. In the distance, the gas platform rose from the water like a massive steel island, bristling with Russian equipment and personnel who had no idea what was coming. At 9:15 local time, Sokol's drone crested the final wave, and the Boyko Tower platform came into crystal clear view through his goggles. The massive steel structure rose 40 meters above the Black Sea surface. And there, mounted on the platform's highest point, sat his target, the Neva radar system that had been tracking Ukrainian operations for months. The Neva radar was one of the few legacy Soviet systems that actually worked well. The K-band system operated at a frequency of 35 gigahertz with a rotating antenna array that could detect aircraft and surface vessels at ranges of up to 45 kilometers. More critically, it could track 200 targets simultaneously and provide real-time targeting data to weapon systems positioned throughout the Northwest Black Sea. Despite its engineering, the radar system could not survive a drone carrying explosives flying directly into its face. The 3 kilograms of explosives strapped to Sokol's drone might not seem like much compared to a cruise missile, but it would be devastating when directed against delicate transmitters and waveguide systems. Through his goggles, Sokol could see Russian personnel moving around the platform's lower levels, completely unaware of the threat approaching from the northeast. The Neva radar continued its methodical rotation, each sweep bringing it closer to potentially detecting the incoming drone. But these small quadcopters have tiny radar cross-sections, roughly equivalent to a large seabird, making them nearly invisible to detection systems until it is too late. At 800 meters from the target, Sokol began his terminal approach. The beauty of these systems lies in human-controlled precision. Sokol could see exactly where he wanted to strike, the junction between the radar antenna and its control unit, the sweet spot that would maximize damage to both mechanical and electronic components. The drone's camera showed the Neva installation growing larger. Soviet engineers had built the system to withstand electronic jamming and environmental extremes, but they never designed it to survive a direct explosive impact. The radar's protective housing was aluminum sheeting intended to keep out salt spray and rain, not high explosives traveling at 60 kilometers per hour. At 200 meters, Russian personnel on the platform finally spotted the incoming drone. Sokol could see them pointing and shouting through the grainy video feed, but it was too late. The quadcopter was moving too fast. One technician reached for what looked like a rifle, but the drone would impact in less than 10 seconds. At 9:20, Sokol's drone struck the Neva radar system's antenna assembly with devastating effect. The explosive charge detonated instantly, sending fragments of aluminum, steel, and electronic components flying across the platform. The explosion was perfectly placed. The radar's delicate waveguide system was shredded, its transmitter destroyed, and its rotating antenna mechanism completely severed in one precisely delivered blow. A drone that cost less than an annual streaming subscription had eliminated one of Russia's best surveillance capabilities. While smoke rose from the destroyed Neva radar, 80 kilometers away, a far more devastating weapon was beginning its approach to the Boyko Towers. Although not 100% confirmed, many suspect it was this weapon heading towards the platform. The Sea Baby drone, cutting through the Black Sea swells, representing Ukrainian maritime warfare at its most sophisticated. It was a 6-meter-long unmanned surface vessel carrying nearly 1 ton of high explosives toward the Russian-occupied gas platform. Unlike the aerial drone, the Sea Baby was purpose-built for destruction, developed by the Security Service of Ukraine specifically for attacking hardened maritime targets. This sleek, gray vessel looked more like a high-speed patrol boat than a weapon of war. Hidden beneath its unassuming exterior was 1,000 kilograms of military-grade explosives, enough destructive power to level a city block. The warhead design was a masterpiece of engineering. Rather than using a single massive charge, the Sea Baby's payload consisted of multiple shaped charges arranged around the bow section. This configuration created a sympathetic detonation effect. When the primary target exploded, it would trigger secondary charges in sequence, creating a prolonged explosion that could demolish reinforced concrete structures. The explosive itself was a mixture of RDX and TNT, providing a maximum blast effect combined with sustaining temperatures exceeding 3,000 degrees Celsius. When detonated against the Boyko Tower support structures, this warhead would create a sustained fireball that would melt steel and turn concrete to powder. Despite its name, the Sea Baby was not crawling towards the target. The propulsion came from twin 200 horsepower inboard motors driving water jets, which allowed it to reach speeds of 49 knots while maintaining a low profile. The twin-engine configuration provided redundancy. Even if one motor failed, the drone could complete its mission. Navigation was handled through global positioning systems, inertial guidance, and real-time satellite communication. With additional fuel tanks, the Sea Baby could operate autonomously for 1,000 kilometers. But human operators maintained control through encrypted satellite links for precision strikes. The drone's design prioritized stealth. Its low-profile hull kept it below most radar horizons, while the gray paint made it nearly invisible against the sea. More importantly, The Sea Baby incorporated multiple redundant communication systems to counter jamming. What made this particular Sea Baby dangerous was its mission profile. The operators had detailed intelligence about the platform's structure, including the locations of storage facilities and support columns. They knew exactly where to go to do maximum damage. As the Sea Baby approached at 45 knots, its warhead represented the culmination of Ukrainian innovation. 1,000 kilograms of explosives were about to demonstrate why Russia should leave Ukrainian waters. The drone was 30 kilometers out and closing fast. Through its high-definition camera, operators could see the platform growing larger, black smoke still rising from the destroyed radar. But their target was the platform itself, ensuring it could never function as a military outpost again. With the Neva radar destroyed, Russian forces were blind to surface threats. Their remaining detection capability consisted of naked eyes and handheld radios. But help was over 100 kilometers away. Through the Sea Baby's feed, operators observed the full scale of the Boyko Tower complex. The platform consisted of multiple levels connected by a steel framework with storage facilities and living quarters. Russian forces had converted the infrastructure into a forward operating base, complete with communications equipment and supplies for long-term occupation. The Sea Baby's autopilot system made hundreds of micro-corrections per second to maintain optimal approach. Unlike human pilots, the navigation computer could simultaneously process coordinates and visual targeting information, maintaining a perfect course. At 10 kilometers out, the Sea Baby activated its terminal guidance. The electro-optical camera locked onto the platform's main support structure, specifically the junction between the drilling platform and the accommodation block. Intelligence determined destroying this specific point would cause the platform to tumble into the sea. The Sea Baby's speed increased to maximum velocity, 49 knots or 90 kilometers per hour. At this speed, the 6-meter-long drone became a 6-ton projectile carrying 1,000 kilograms of explosives. The kinetic energy alone would be devastating, but combined with the massive warhead, the impact would be catastrophic. Russian personnel finally spotted the threat. Through the camera, operators saw figures running across the deck, pointing toward the approaching vessel. Some grabbed rifles, others shouted into radios, but their actions were futile. The Sea Baby was less than 5 minutes from impact, and no weapon on the platform could stop it. The defensive preparations were inadequate. Small arms were designed to repel boarders, not high-speed drone strikes. At 2 kilometers, the Sea Baby was committed to its final approach. 1,000 kilograms of explosives were about to transform the Boyko Tower into a twisted wad of metal. The drone struck the main support junction with the force of a freight train. The shaped charges focused explosive energy directly into the supports, creating a demolition effect engineering textbooks would describe as catastrophic structural failure, but what I would call blown the F up. Within the first second, temperatures at the blast center exceeded 3,500 degrees Celsius, melting the steel framework holding the platform together. The accommodation block where Russian personnel lived disintegrated, its prefabricated walls vaporized. Anyone inside had no chance of survival, but the destruction was just beginning. The Boyko Tower was an integrated system. When the warhead severed the main connections, it triggered a cascading collapse. Storage facilities filled with equipment added fuel to the fire as their contents exploded in secondary detonations. The platform's fuel storage tanks ruptured in sequence. Each explosion sent fresh flames hundreds of meters into the air, creating a pillar of fire visible from space. The smoke plume rose over 1,000 meters into the sky, a visual monument to the attack's effectiveness. Within 5 minutes, the entire upper structure of the Boyko Tower collapsed into the sea. What had been a multi-level military platform was now a twisted mass of steel and concrete jutting from the water like the ribs of a massive corpse. The accommodation blocks and storage facilities were gone, replaced by debris floating on oil-slicked water. The few Russian personnel who survived the initial blast on the lower levels were trapped on unstable wreckage with no possibility of rescue. Help was hundreds of kilometers away, and the fires made helicopter evacuation impossible. Ukrainian satellite imagery captured the scene 2 hours later. Where the Boyko Tower had once stood as a symbol of Russian occupation, only burning wreckage remained. The platform that had served as a forward surveillance post and logistics hub had been completely demolished by 2 Ukrainian drones that cost less than 2,200 copies of a standard video game. Please like and subscribe.